network. So I have a subnet over here.
Two possible routes
That's
to get to the same network.
7/64 that exists on both R2 and R3. I have a primary link that's gig. I have a backup link that's T1 that's static. Same configuration that we did with IPv4. So if I look at the routing, we're looking at the cost, right? It's going to pick the least cost, a static route via 111.9, which has a distance of 130. So we can see that either by I see static route and then look for the static, or we can show that particular route, and the static route has a distance of 130. So the static route would be the T1, not really the one we want. So we would have to manipulate, again, administrative distances for various types of routes. Connected routes are 0, static routes are 1. Neighbor discovery protocol routes are 2 with IPv6. So this one's different because we didn't have neighbor discovery in IPv4. EIGRP, OSPF, RIP, unknown or unavailable gets the highest administrative distance. So we can then fix our IPv6 route so that the learned route via OSPF will take precedence over the static route by changing the administrative distance. Same thing we would do with IPv4. All right, so this is a sample topology. We have the 9.1 network, the 9.2 network, and the 9.3 network. And if we look at our routes, we put in, so this is on R1. Is this on R1? Yeah, so we put in IPv6 and we put in the wrong prefix, right? We did 3 as opposed to 3:3 or 3. Where's 3? 3::. So this is clearly not going to work, right? It's not going to pass traffic appropriately. In this one, we put on gig 02 and then the link local address. But what link local address do we use to get to 3? From 1. It would have to be this link local address here. And this one they used AAA 9. I don't know what that is. In this particular route example, they used FE80::2, but forgot to put the outgoing interface, and that won't work because it's using link local. We have to specify the interface. In this particular route here, they used the wrong neighbor address. They used 2.1, which is itself, as opposed to 2.2. And in this final one, they put the wrong interface on R1. So it's going to try to go out, back out this interface as opposed to out this interface. Routed to the link local. So just some incorrect routes. None of these would work. So iOS will reject an IPv6 route command with link local and no outgoing interface. So if you try to put that in, it says the interface has to be specified for link local next hop. So it does tell you that you have to do that. So if you try to use FE80, you do need to, before you do that, specify the interface you want it to go out. Now, we also have the ability for devices to discover routes via the neighbor discovery protocol, which are neighbor solicitations and neighbor advertisements. So this PC comes online and he says, okay, I am online. I have an address. And it's doing a solicitation saying, I'm looking for a particular host. In this case, I'm looking for 122. Here, 122. that's a neighbor solicitation packet that goes out. If that computer happens to be on the network, it will send back a neighbor advertisement that says, yep, here is my IP, that's me, and I have this MAC address. Here you go. So this takes the place of ARP, right? So IPv6 doesn't use ARP, it uses neighbor solicitation and neighbor advertisements. So on the R3, they're doing a show IPv6 neighbors, and it's showing us the neighbors that exist. So if we go back to our diagram real quick. Oh, we can't. This is R3. I have to go way back to the diagram. But the neighbors are what is seen through neighbor advertisements. And we see the MAC address, the link layer address, and the port that they're reachable from. Then we see the address. In this case, there's two addresses. They're actually the same device, the global address and the link local address for the neighbor of R3, whichever device that happens to be, which is this PC. The other thing that we can use the neighbor discovery protocol for is for finding a router. So as a PC, I want to find a router, then I can do a route solicitation, an RS, and say, I'm looking for routers. So any routers out there? And then all the routers, if there's more than one, will reply with a route advertisement that says, yep, I am, and send back their link local address to say, here's how you can route. The PCs will also use this process to determine what IP addresses they need. So they will use a route solicitation to determine what network they're on. So if there's a global unicast address on here, the route advertisement will go out with a global unicast address, and then this PC will know that it needs to assign itself an address in that same range. So it learns from the router the prefix, and then it either randomly or uses EUI64 to assign itself the rest of the IP address. And just for sanity's sake, if we're using random, we actually have to do an additional process, the duplicate address detection. Even if we're doing MAC address based, we still are going to do random detection anyway. So do the detection, send an NS for myself. So I'm doing a neighbor solicitation. This guy will send it out for himself, say, I'm looking for me out on the network. If it gets back a neighbor advertisement, then it knows it's a duplicate. So in this case, these two PCs have the same IP, IPv6 address. This guy sends out a neighbor advertisement that says, hey, I'm looking for my own address. PC2 says, hey, that's my address. Here's my MAC address with the neighbor advertisement. PC1 now knows it can't use that IP address. So here are the different functions for the neighbor discovery protocol. There's router discovery, which is two messages, the route solicitation and a route advertisement. Any host can discover info from a router discovery, so clients will send out these and listen for a route advertisement. Only routers, devices configured as routers, will send out route advertisements. Okay. Likewise with our prefix length discovery. So when a machine comes online, it is going to send out a route solicitation looking for the network prefix and listen for route advertisements coming from, again, only routers to learn the prefix and length so it can assign itself an IP address. Neighbor discovery, again, we have neighbor solicitation, neighbor advertisements, except now it's any host I can find all the neighbors on my subnet via neighbor solicitations and neighbor advertisements. And we also use that for duplicate address detection. We'll send out our own address as a neighbor solicitation and listen for an advertisement. Again, any host. Does that make sense? Any questions on the IPv6 static routing or neighbor discovery process? Anyone still awake? Apparently not. There, Marcel, thank you. Thanks, Juan. All right. So that's our section on IPv6. There is IPv6 for